prematured. He was not expected to survive even the first day of his life. He had a complex character, vindictive yet restless in nature. He could study 16 hours in a day and yet showed no sign of tiredness, and he could further and further study. Yes, you guessed it right. I'm talking of Sir Isaac Newton, one of the greatest philosopher, mathematician and physicist of our time. Today is 25th of December, and as per the old calendar, this date marks the birthday of Sir Isaac Newton. In this video today, on this auspicious day, I'm going to talk a little bit about this great person's life. I know that it is not possible to cover his huge mammoth discoveries and contributions to physics, mathematics and to the world of science, but yet this would be my humble effort to pay a dedication, to pay my respect and honor on this date, 25th of December, marking the birth date of Sir Isaac Newton. Happy birthday, Sir Isaac Newton. My name is Shaunak and you're watching this video of Isaac Newton on my channel, Physics for Students. Warm wishes and a happy Christmas to all the viewers, and this is a video on the life and works of Sir Isaac Newton. Born on this date, 25th of December 1642, as per the old calendar, Sir Isaac Newton was born. He is considered to be one of the greatest mathematician, philosopher, physicist of all times, and his book Philosophiæ Naturalis Principia Mathematica first established the rules of classical mechanics in a formal way. Isaac Newton is also considered to be one of the key figures in what is called the Enlightenment Revolution, and he also made sufficient contribution in optics, geometry, physics, mathematics, calculus, as well as is known for his astounding discovery in gravity. So in this video, I would try to cover the main significant contribution of Isaac Newton, about his interesting and complex character, his life, and further his contribution, how it changed the entire world of science and mathematics. So as per the Julian calendar, which was the calendar maintained during that time in England, Isaac Newton was born on 25th of December, that is today, 1642. But if you maintain the new style, then you will see that he was born on 4th of January 1643. So now this is something very interesting, that a person has got two dates of birth. One is today, 25th of December, and another is 4th of January 1643. Now Isaac Newton was actually born on an hour or two after midnight at Woolsthorpe Manor in England, and he lived at Woolsthorpe by Colsterworth, a hamlet at Lincolnshire. A little bit quick details about his background. Now his mother, his name was Hannah Asicock, and his father's name was also Isaac Newton. A quick recap about a little bit about Newton's mother on your screen. He got married in 1623. His father's name was James Asicock. He married Isaac Newton Sr., Newton's father, who died 3 months before Newton's birth, and he remarried Reverend Barnabas Smith, and his mother died in 1679 out of typhoid fever. Now remember that Isaac Newton carried a very disturbed childhood. The reason is that he could not see his father because his father died 3 months before his birth. And when his mother Hannah again remarried Reverend Barnabas, he was asked to live with his grandmother, and disliked his stepfather and maintained a kind of an enmity. And in many of his letters, Newton has written that he threatened, and here is the writing, threatening my father and mother Smith to burn them and the house over them. So that was a kind of a childhood which is very unfortunate for a great thinker and philosopher like Newton. He was born, he could not see his father, neither he could see his mother, because Reverend Baron Smith remembered that when he married Hannah, he told that I only wanted to get married to you. I don't want any stepson or others. So Hannah unfortunately had no other options but to leave Isaac Newton down to his grandmother, and where he gradually grew up. But the thing is that that kind of an enmity which Isaac Newton maintained with his stepfather and others, you will see that in his future development of characters, the kind of police philosophers and mathematicians had, it is not absolutely Newton's fault. It is the fault that unfortunately his childhood has been. All this taken together, because he has got a very disturbed childhood, do you think that it at all hampered Isaac Newton to become an Isaac Newton? What was his education about? A child who is born and brought up with this kind of a childhood where neither he could see his father, neither he could see his mother, carrying an enmity towards his stepfather. What could be the upbringing of that child? Just think in that way. And what could be his schooling? Let us find it in the next part of our video. Now, if you have gone to the market town of Grantham in England, you will find there's a lot of hustle and bustle which is coming out from a nearby store, which is coming out from a nearby school. Now, this is the school where Isaac Newton has been educated. So it is located on Brook Street. The school site was expanded to further as an historical place to visit, because if you see the houses and the construction of the Grantham school is as old as 1494 and 1494-97, and the address reads that Grantham, Lincolnshire, NJ 31 6 RP, England. Now, it is in the school, if you can see, I have given a kind of a small photograph and illustration of King's School where Newton was educated, and here you can see that is the sign of Isaac Newton now being properly preserved, because during that time nobody knew that Newton would be Newton. Remember that during his school days he was bullied and he was harassed by a lot of young fellows who thought that he is not a proper child, because Newton never talked, neither he communicated with anybody. From the age of 12 up till 17, he was educated at Grantham School, where he was given a fair, modest, education in Latin, in ancient Greek, and a significant foundation of mathematics. He was removed from the school and returned to Woolsthorpe by Colsterworth by October 1659, because remember, by this time Reverend Baron Smith has also died, and his mother Hannah thought that he would bring his son Isaac in order to do what? Not mathematics, not physics, but to do farming. Yes, and this is the thing which Isaac Newton hated. So his mother brought him to make him as a farmer an occupation, and it was during that time that a very important person, Henry Stokes, the school teacher of Grantham School, motivated his mother that no, you should not ask your son to do farming, he can do better thing, and he motivated partly and asked him again to send back to school. Now here comes the first, I would say first achievement of Isaac Newton. He is being bullied and harassed by most of the schoolmates of his school at Grantham, and he distinguished himself by building sundials and models of windmills. You understand? A boy of this age, he could make sundials and windmills through his own hand, and that actually shows the genius of Isaac Newton. Neither his mother, neither his father, nor the farming, nor the disturbed childhood could actually make him any hindrance in his further education. He is determined and focused. He is going to change the world, and at a very young age, he started making sundials and windmills, and that actually categorized and made him a separate human being from all the school students of Grantham College. Now, going ahead with the education part, what was the next step that Isaac Newton could do? Because there was a formidable problem, because his mother wanted him to become a farmer, but he wanted to become something else. What was the next step that Isaac Newton took? Let us find out in the next part of our video. Now, Newton arrived at Cambridge in 1661. Remember when the movement had started. What was that? a new scientific movement. Now remember, during that time, astronomers like Nicholas Copernicus and Johannes Kepler had elaborated the heliocentric system of the universe. Galileo had proposed the celestial mechanics, and led by René Descartes, philosophers had begun to formulate a new conception of nature as an intricate, impersonal and inert machine. Yet you remember, as far as the universities of Europe, including Cambridge, is concerned, they were still, around the, I would say, the outdated Aristotelian view. They continued to stronghold the Aristotelianism, which rested more on the geocentric view of the universe and dealt nature more with a qualitative rather than a quantitative term. Now, as usual, Newton came to Cambridge and he was thoroughly influenced by Aristotle's view of philosophy, and he started digging deep into Aristotle's Newton busy. That is, he found the discoveries and the works of Descartes more appealing, more attractive, more cool, where he started building sundials and windmills. Now he is moving into what? Into Cambridge, into the university. The university was primarily dominated by Galileo's, Kepler's and Copernicus thinking. Aristotelianism was much more prevalent, but Newton found that why don't he look more into Descartes' philosophy, into Cartesian philosophy, and dealing more into the quantitative aspect of universe rather than the qualitative aspect. Here we find something which is called a set of notes, which is right now in the Cambridge Library. The Latin says Questionius quadam philosophicae, are certain philosophical questions. It is a kind of a notebook which Isaac Newton started writing, and this notebook served and ushered a new thought, a new era of philosophical thoughts. In this notebook he made certain notes which was not Aristotle's view. It was a view of the new philosopher of Descartes. It's a new view in which he would start thinking and looking the world of science in a new way. What was that notes that Newton was writing? Let us find out in the next part of our video. Certain philosophical questions. Okay, so first I would like to make the viewers a note. Remember that these are the notes that Isaac Newton wrote during his Cambridge time, and these notes reveal something very important. But before that, I would like to tell you that it started after 8th of July 1661, the date on which Newton arrived at Trinity College, right? He made notes of his observations of comet. Other datings of the first entries are based on his handwriting. Now, the question is revealed that Newton had discovered the new concept of nature that provided the framework of scientific revolution. Now, remember that he has thoroughly mastered the work in atomism. The question is also revealed that Newton had already inclined to find the latter more attractive philosophy than the Cartesian natural philosophy. So the two traditions of natural philosophy, the mechanical and the hermetic, although antithetical though they appear, continued to influence the thought of Isaac Newton, which supplied to his fundamental scientific career. Now the question contains notes, as you can see, of Descartes, Galileo's dialogue concerning the two chief world system, Robert Boyle, Thomas Hobbes, Nem Debye, Joseph Cannibal, Henry Moon and various others. In April 1667, Newton returned to the University of Cambridge in October, and he was elected as the Fellow of Trinity. Now his academic professor, who was another great person, Professor Isaac Barrow, who was anxiously watching the development of thoughts of Sir Isaac Newton, succeeded him, and only 1 year after receiving his MA, Newton was elected as a Fellow of the Royal Society, FRS, in 1672. So what is most important during this time is this question is, which is often most of the in the videos and talks of Isaac Newton, you will see that this is being, I would say, this is quite being ignored, because it is in this particular notes when Newton started thinking more about the philosophies, the scientific revolutions, and what actually captured his mind to discover something new, which we know what it is, and the entire world has witnesses. Now, it is in this particular, questions, or what I would say, certain philosophical questions, that his influence on the scientific thoughts. Not ignore these certain philosophical questions, a set of notes which I would say fomented Newton in order to think in a much more scientific way, giving out the Aristotelian view and going more into the new scientific view. Now remember one thing, that nothing comes without a cost. Now, we encountered COVID from 2020 to 2022. We were all shut down. There was a total, lockdown in the entire world was witnessed. But what, as human beings, we did that? Let us try to find out that during that time, what was ensuing. Something similar to COVID, something similar to coronavirus, which plagued the entire London. And what was Isaac Newton doing during this time? Let us find out in the next part of our video. On July 25th, 1665, the New York Times reports that a 5-year-old boy, John Morley, on the parish of the Holy Trinity in Cambridge, was found sick. The doctors came, they checked, and they found some spots on his chest. It was the bubonic plague. London is affected during that time with a great plague, and everyone was flying away. Everyone was escaping London, and one person, one young boy was also escaping. He was also running. His name is Sir Isaac Newton. Now, among those young scholars, Isaac Newton came to run away from Trinity College in Newton's home, a farm which is called Woolsthorpe, lay about 60 miles north of the university, suitably distant from the nearest town. Remember that around 1 lakh people died in London, almost a quarter of London's population, in 18 months. But what was Newton doing during this great plague? Let us find it out with a few significant points right on your screen. Now, he shut himself up because during that great plague, nobody can go out. Quite natural. Nobody can go out. Nobody can do anything because almost everybody was dying. He created major insights across the vast areas of mathematics. He invented calculus, and he made major contributions in analytical geometry. He also created physics. He performed experiments to demonstrate gravity's pull, and he also found out the famous universal law of gravitation, the theory that would connect every object in the cosmos to the flight. Richard S. Westphal, his only biographer, told that he began to think about the most pressing questions in science while still studying for his exams in his rooms at Trinity College, and developed the full theory of gravity, and whatever may have enabled Newton to produce optics. This is the right time that he shut himself up in the farmhouse and started experimenting by allowing a ray of light enter his dark chamber and reflect and refract through the prism, and finding out optics, the colors of light and whatnot. When he was asked that how he could find out gravity, he just replied, by thinking on it continually. So this is very important, that during the time when London was plagued, there was a huge plague which is going on. Almost the entire people of London, almost they are affected. Everyone was dying. Newton shut himself up. And that is how a brilliant mind really works, that he made use of this time without going out, meeting with his friends, doing his lectures. He shut himself up at the farmhouse at Woolsthorpe Manor, and he studied gravity, invented optics, invented calculus, worked on the laws of motion. And how he did that? The famous line, by continually thinking on it. It was during this time which we call as the annus mirabilis, or I would say the marvelous years, just like Albert Einstein. This was the annus mirabilis of Isaac Newton. We find out that during the time when London was suffering from plague, Isaac Newton was doing something great. He was changing the entire dynamics of classical mechanics by discovering something. What were the discoveries and how did he find out? Let us find it in the next part of our video. Remember that Leibniz, however, published or invented calculus almost 9 years earlier to that of Newton. So the date says that Leibniz published his discovery of differential calculus in 1684, 9 years before Newton normally published his fluxion notation in calculus in part during 1693. So it was 1684 and 1693. Now remember that Newton's publication or Newton's way of arriving at calculus was using the word fluxions. Now the fluxions actually is something which is called a momentarily flux, a momentary change, right? Now in this book was published in 1671 and it was later published in 1763, and fluxion is what is called Newton's term for a derivative. He originally developed the method at Woolsthorpe Manor during the Great Plague of London. Remember, fluxion is what is called an instantaneous rate of change. Right, what we called as gradient or a change, that is what is called fluxion, instantaneous rate of change, and this is the term which was introduced by Isaac Newton, which is called the time derivative. Now, although we in today's world we use Leibniz notation of calculus, Newton determined the area of a curve by first calculating a momentary rate of change and then extrapolating it further. Right on your screen you will see Newton attempted to avoid the use of infinitesimal small change by forming calculation based on the ratio of changes. In the Methodist fluxionism, he defined the rate of generated change as fluxion, which is represented by a dotted letter, and the quantity generated he defined as a fluent. For example, if x and y are fluents, then x dot and y dot, what we call derivatives, are basically called fluxions. Now Newton actually knew earlier that when he was describing that in forms of the total area calculation in terms of instantaneous rate of change, there was a problem, and the problem is actually the property of inversion, and he later created an expression for calculating the area of a curve, and it was this book which you can see right on your screen, De Quadratura Curvarum. That is the book which revised calculus of ratios and continued to be developed, and as was maturely stated in the 1676. So this is the way in which Newton discovered calculus, invented calculus. Leibniz discovered it from the philosophical point of view. Newton discovered it from a mathematical point of view. This book is very important because it was Newton who first coined the term fluxions, which mean instantation using the infinitesimal by forming calculation based on the rate of changes. So we still use some part of Newton's calculus by using a single dot for a single derivative, double dot for a double derivative, and it is this word fluxions or fluents which marked the usage of calculus, and that is how Newton discovered calculus. But apart from the discovery of calculus, how he wrote the equations and the formulations of calculus, which book it was, let us find out in the next part of our video. Okay, Philosophiæ Naturalis Principia Mathematica, in English it is called Mathematical Principles of Natural Philosophy, and in 1687 still to be considered one of the greatest and one of the profound book ever written in the history of science. If you have not gone through Philosophiae Naturalis Principia Mathematica, I would strongly recommend please go through this book. Whether you understand or not, that is a different issue, but this is a Bible for every science and physics lover. Anyone who really loves science should have this book, at least a photocopy of this book in your library. So what was the significance of this book? First of all, this is the book which actually, I would say, formalized mechanics. This is the book which first lays down the Newton's 3 laws of motion, the first law, the second law, the third law. This is the book which also dealt deep with the Kepler's law, unified celestial and terrestrial physics under one set of laws. This book also encompasses explanation of physics, strongly definition of mass, force, motion, gravity, movement and lunar motion, planetary motion, tidal forces and whatnot, right? The Principia established mathematics as the language of science. Mathematics became a means of knowing about the universe. So the prime importance, and remember that this book was published not by Isaac Newton. This book was published by Edmund Halley, and Edmund Halley almost exhausted all the money from his pocket in order to publish, in order to pursue the publishers of the Royal Society, and he went out of money when he first pursued the publishers to publish Philosophiæ Naturalis, Principia, Mathematica, a very important book in the history of science. Now let's quickly look into what are the topics that we are covering in the book. Right on your screen, book 1 is called De Motu Corporum, or on the motion of bodies, concerned motion in the absence of any resisting medium. It opens with a collection of mathematical lemmas on the methods of first and last ratios and so on. Part 2 of the contents originally planned for the first book was divided out of a second book, which largely concerned the systemate on the system of the world. It is an exposition of many consequences of a universal gravitation, especially divided. So on the motion of bodies, the first, second is more or less the same, and third on the system of the world, where he expounds and gives more detail onto the equations of gravity. Most importantly, this is the book which first laid the foundation and the cornerstone of what is called the deterministic classical world. So the Principia Mathematica in one way actually formulated and laid the foundation stone of his discovery of gravity. What else was one of the most significant contribution of Newton? Let us find it out in the next part of our video. Now today we all know that white light is composed of several different colors, right? And we can understand when we see rainbows, etc. But if we owe our gratitude and immense thanks to Sir Isaac Newton, who was the first person to discover this, and his works on optics are phenomenal. Now, it was a problem during that time. Was color a kind of a mental image? Is it color is out there, or is it in your head? Is it just kind of a mental thinking? And it was during this time that the British philosopher John Locke actually told that color is both objective property and an idea. But as you know, science won't rely upon anything until it is properly proved. So the first experiment that Isaac Newton did was with the prism. He allowed sunbeam to glare down or peep through these dark chambers and grow into a small window shutter, and it will go through the prism. Now, as expected, he saw the colors of the rainbow on the wall, but when he examined further, he found out that the refracted light instead of forming a kind of a circle, formed an oblong shape. And that is what showed the color length of the spectrum. It was about 5 times of its breadth. Newton guessed it correctly, that the oblong shape was due to the differential refrangibility of rays of different colors that are present in white light. So this is the first experiment. If you go to internet, you will sometimes find the photograph of Newton shining light from that window, going through a prism and diffracting and producing some other light. It was Newton who first discovered that light is composed of certain other colors, and color is not in the mind, it is right there inside the light. He also discovered what is called a telescope. Now remember, during that time the telescope markers were familiar, but there are a lot of imperfections with the instruments. You mean to see there were aberrations, spherical lenses were failing to converge lights, and Newton was the first person who used what is called refracting lens, or now today we know there are 2 types of telescope, one a refracting telescope and one is a reflecting telescope. So he used reflection of light, converging the light rays to a single point so that the unwanted better is the magnification. But there was a technical difficulty. That is, how could you polish the metal in order to make the lens much better? Now Newton went to his furnace and he used a cast of a tin and a copper and refined it by grinding and grinding and grinding with great clear and strength. So the discovery, as you can see right on your screen, this is a small image of the reflecting telescope which Newton used in order to move apart those unwanted colors to give the further magnification. He also found something which is called the corpuscular theory of light, that light is complex and heterogeneous, and that the phenomena of colors arise from the analysis, the discovery of light, optics, prism, and most importantly a reflecting telescope, which would further give science and humanity further ways to discover. And today we have got Hubble telescope and JWST, but the founder was Sir Isaac Newton. But other than optics, remember, there is one important discovery by which Isaac Newton is known. What was that? Let us find out in the next part of our video. So if you today go to Woolsthorpe Manor, and if you have visited Isaac Newton's residence, you will see that the apple tree is still lying, and the apple tree is properly guarded by a fence, because it was, the legend says that the apple fell on Newton's head, and he thought, why did the apple fall down instead of going up or moving right and left? So he showed us that force that makes the apple fall, for that hold us on the ground, and it is the same force that kept the moon orbiting around the planets. Now the Principia, which was published on 5th July 1687 with encouragement and financial help from Edmund Halley. In this work he stated the 3 laws of motion. Together with those 3 laws of motion and the planetary orbit, the formulation of the Newtonian gravitational, Newton's gravitational law was found. He used the Latin word which is called gravitas, which means weight, that would become known as gravity, and defined by the law of universal gravitation. Remember, there is a common misconception that the value of G, capital G, universal constant, it is not who Newton has discovered. It was discovered by some other scientist. Who was that scientist? Let me know if you can find out. I think you already know in the comment section of the video. So these 3 laws, which has been published in Principia Mathematica, together describe the relationship between any object, the forces acting upon it, and resulting motion, laying the foundation of classical mechanics. Newton by that time has grown up Newton. Everybody knew that he is an immense character who could lay the foundation, revolutionize physics, mathematics, calculus, optics, motion, everything which was possible. But there was a very, very interesting story which was between Johann Bernoulli, another Swiss mathematician, and Isaac Newton. What is that story? Let us find it out in the next part of our video. In June 1696, famous Swiss mathematician Johann Bernoulli framed a kind of a mathematical problem which he published in what is called the Acta Eruditorum, the first German scientific periodical. What was that problem? You can see it right on your screen. Now, this is something which is called a Brachistochrone problem, and it was given in order to find out the possible path that it would take. Now, this mathematical problem, even Johann Bernoulli already knew how to solve it. He threw it as a challenge, and he had given 6 months to solve. Now, it was during this time that Leibniz was also one of the greatest intellects in his history, and he requested that, no, let us extend this time further to a deadline. Now, it was on the afternoon of January 29th, 1697, that Isaac Newton returned from his work for Mint, because he was working as a warden in Mint with certain other problems which we will see in this video on some currency problem, and he found out that Johann Bernoulli has sent this Brachistochrone problem, and it was around 4 p.m. 4 p.m. in the evening when he found out, and he stayed awake all the night, and at 4 a.m. he solved out the Brachistochrone problem and sent through a post, and that too in an anonymous name, not in his own name as Sir Isaac Newton. Now, he solved the problem, as you can see right on the screen. This is Isaac Newton's handwriting, which shows that he has solved the problem and saved it anonymously to Bernoulli. Although Bernoulli opened the letter, and what he found is not a signature but just an anonymous name, and he found out that Isaac Newton has solved the problem. And it was during that time that Bernoulli made this famous remark, "I know, or we recognize the lion by its claws." The story gives some idea of Newton's power, since Johann Bernoulli took 2 weeks to solve, and Isaac Newton, remember, solved it just within 1 day. And Bernoulli made the quotation, Bernoulli made this famous remark, "We can understand the lion by his claws. I don't need to see the lion by its face. I can just understand the lion by his claws." And Newton replied to Johann Bernoulli in this way, "I do not love to be pestered and teased by foreigners about mathematical things." That is how genius was Newton, who could solve a problem which would take 2 weeks to 3 months for any brilliant mathematician to solve. And that is why we call that we can understand Newton by his claws. We don't need to see his face. During the last years, Isaac Newton suffered from urinary incontinence, or a urinary tract problem. In January 1725, he was seized with violent cough and inflammation of the lungs, which allowed him to return to Kennington. In that next month, he had a case of gout, and then continuously there was a problem with his health, although his health improved. And on 28th of February 1727, he went to London to preside at a meeting of the Royal Society. But again, his health condition forced him to come back to Kennington. On 4th of March, he was detected with a gallbladder stone. He was suffering greatly, and on 18th of March, he became delirious around 6 p.m. and stayed in that state until he fainted around on 18th of March due to the immense pain on his gallstone, and he stayed in that delirious state until 20th of March 1727. He died between 1 and 2 in the morning. He never married. He lived as the monk of a science, having channelized his entire energy and life to his work. He was a complex character. Neither he met with somebody else, but his burial, which took place for the first time, a scientist was buried at Westminster Abbey. The burial took place with great pomp and grandeur, with all the kings and knights and people around the entire world, or almost England, participated in the burial ceremony of Sir Isaac Newton. Now that was the end of Sir Isaac Newton, how he died. He became delirious, he suffered from a gallstone pain, also he suffered from a gout, and he died with around 20th of March 1727. He was the first scientist to be cremated in Westminster Abbey. Now right on your screen you see this is a kind of an epithet which is written. It is in Latin, and I will read out what it is written in English. "Here is buried Isaac Newton Knight, who by strength of mind almost divine and mathematical principles peculiarly his own, explored the course and figures of the planets, the paths of comets, the tides of the sea, the dissimilarities in the rays of light, and what no other scholar has previously imagined, the properties of the colors thus produced. Diligent, sagacious, and faithful in his expositions of nature, antiquity, and the holy scriptures, he vindicated by his philosophy the majesty of God, mighty and good, and expressed the simplicity of the gospel in his manners. Mortals rejoice that there has existed such and so great an ornament of the human race. He was born on 25th of December 1642 and died on 20th of March 1726. Well, about his personality, there are various rumors that he got engaged once, but as far as my research goes, that he was a monk of science. Neither he got married, neither he was engaged with any woman. His entire life, his entire potency and energy was directed only towards science, discoveries, and mathematical and physical formulation of his thoughts, which leads to astounding discoveries. And whatever science that we are doing today is just because of Sir Isaac Newton. Now, the French philosopher Voltaire, who was in London at the time of Newton's funeral, writes, "He was never sensible to any passion, and was not subjected to the common frailties of mankind, nor had any comments with women, a circumstance which was assured by the physicians and surgeons who attended him in his last moments." Now, despite his wealth of discoveries, remember, Isaac Newton was working with the Royal Mint of Britain, England, during that time, because Britain was suffering from a problem where there was problem with currencies where, there were theft of currencies, and he was trying to overcome, and he framed a kind of a currency which saved the Queen from getting demolished. As personality, Newton, this is written by, vain and vindictive in his later years, when he tyrannized the Royal Society and vigorously sabotaged his rivals, says the Royal Society's rees. Now, Newton's merciless nature, when he was out and he was constantly, trying to find out those who forfeited the Queen's coin, right? So he was almost like a detective, right? He was trying to find out those who were, and he was making them making them feel the punishment, and almost he made sure that the forfeiters could hang them in the gallows. So that was a very kind of a complex character. Historical evidence also shows that he used to perform alchemy, which was a kind of a knowledge which would turn the metals into gold. However, whatever it was Sir Isaac Newton who discovered gravity, calculus and everything. A person who has got complex characters, very vindictive, very revengeful, never married, never got any woman association, neither he sought for any huge amount of wealth, although he accumulated a lot of wealth and which he lost also. A kind of a complex character which creates a kind of a mystery, and that creates a kind of a notion to know more about Sir Isaac Newton. So that's all. I would like to conclude this video. This was a very small attempt of mine to pay a humble tribute of this great person on the 25th of December as per the old calendar, which marks the birth date of Sir Isaac Newton. Now, among his many discoveries, it would be I would say it would take a huge long list, starting from gravitation to calculus to laws of motion and on and on and on. I would like to conclude a small quotation which Isaac Newton himself wrote in a letter to Robert Hooke, which shows that in spite of being arrogant, vindictive, very egoistic, fighting in nature, yet he was humble in his mind. This is a letter which he wrote to Robert Hooke, and I think it is around 5th of February 1675, and the last line of the letter reads as follows: I do not know what I may appear to the world, but to myself I seem to have been like a boy playing on the seashore and diverting myself in now and then, finding a smoother pebble or a prettier shell than ordinary, whilst the great ocean of truth lay all undiscovered before me. So you see, that great genius of Sir Isaac Newton is also telling that I am just like a boy playing on the seashore and diverting myself in now and then, finding a smoother pebble or a prettier shell. And he says at the end that the great ocean of truth lay all undiscovered before me. That is the humble attitude. That is how great that in spite of being born and brought up in such kind of ocean of undiscovered truth lies undiscovered in front of me. Thank you for watching this video. Wishing you all a very Merry Christmas and a very Happy New Year. This is Shaunak signing off from this video of Isaac Newton's life, promising you to come back with more videos on physics and mathematics and more great surprises, and filling the next new year 2023 with further videos helping and trying to educate everybody and educating myself with all those thoughts and ideas which the world offers to me. Thank you very much. Merry Christmas and a Happy New Year.
Now, you can be a part of our team. You can send your scientific articles, essays, research papers, lesson plans on a particular subject of science. For further details, please write to us at editor@physicsforstudents.com. Stay safe and happy.